Let us discuss how to construct the saturated calomel electrode. So for the construction of saturated calomel electrode, this glass tube is required for us. And this glass tube, which is required for the construction of saturated calomel electrode, in turn contains two glass tubes. The one is internal glass tube and the external glass tube. Now in the internal glass tube, the platinum wire, you can see the platinum wire here. So the platinum wire is resting on the mercury, on which mercurous chloride is present. In the internal glass tube, the platinum wire is resting on the mercury on which the mercurous chloride is present. What is the mercurous chloride? Mercurous chloride is calomel. The trade name of mercurous chloride is calomel. So since this particular electrode utilizes the calomel as one of the component or the substance, this particular electrode is called as calomel electrode. Now we have to discuss why it is called as saturated calomel. Because if we see the external glass tube, outer glass tube, this outer glass tube contains the liquid. You can see the liquid. Outer glass tube contains the liquid, and this liquid which is present inside this particular outside glass tube is nothing but the saturated KCl solution. So saturated KCl solution. And in order to ensure the saturation of the KCl solution, we have to dip in the beaker comprised of saturated KCl. We have to dip it in the saturated KCl solution which is taken in the beaker, and this should be connected to one end of the potentiometer. So this is how we can construct the saturated calomel electrode. I hope you got this.
Are very much aware that three chemicals are involved in the saturated calomel electrode functioning. The one is mercury, and the second one is mercurous chloride, and third one is saturated potassium chloride. Now what is the function of these three chemicals which are a part of the saturated calomel electrode? The mercury is the one chemical which acts as anode and undergo oxidation during the functioning of this particular calomel electrode. The second chemical, which is a mercurous chloride, will act as a cathode and undergo reduction during the functioning of this particular saturated calomel electrode. And third chemical which is involved in this particular saturated calomel electrode is saturated potassium chloride, which acts as an electrolyte. So this is the basic information I am providing for you in order to understand the chemical reactions involved in the saturated calomel electrode. So initially, the reactions at anode. Now already I have discussed that the mercury is the one which acts as anode and undergo oxidation. Now there should not be any ambiguity, there should not be any dilemma, right? So which chemical acts as anode and undergo oxidation? Mercury. So do remember that. 2 moles of mercury undergo oxidation and results in the formation of Hg2 plus 2 and loses the 2 electrons, because loss of electrons is the oxidation, right? Loss of electrons is the oxidation. Now you will be in a search of the next reaction involved in this. So instead of learning or memorizing in the proper fashion, what you will do is you will mug up. You will practice it 5 to 10 times on the paper. There is no need to practice any of the chemical reaction. There is no need to memorize any of the chemical reaction. There is a concept behind each and every chemical reaction. If you understand the concept, then it's very easy to write any of the chemical reaction without any ambiguity, without any dilemma. Right. Now, What is formed in the first step? The mercury acted as anode and undergone oxidation, producing Hg2 plus 2 ions and losing the 2 electrons. Now, what could be the next step? Next step is the stabilization of this Hg2 plus 2 ions. So, do remember that nature hates to be in the ionic form. Nature hates the ionic form. The cation or anion, whatever it is, it won't want to be in the ionic form, because ionic form of any of the substance or any of the species is not stable in the nature. So it wants to be converted into the molecule form. Once it is converted into the molecule form, then it will attain the stability. Now, what is this Hg2 plus 2? What is the Hg2 plus 2? The plus represents that it is the cation. Right? It is the cation. Now, in order to lose its charge, that is, in order to attain the stability, so it should react with anion or the cation. As it is the cation, it should react with the anion. The cation cannot react with the cation, anion cannot react with the anion. The cation reacts with the anion and anion reacts with the cation. Now, as in the first step, the cation has been formed. The next step is the stabilization of this particular cation, that is Hg2 plus 2. Now, Hg2 plus 2, by its charge, it is amply clear that it is cation. Now, in order to stabilize itself, what it will do, it will try to grab the anions present in its vicinity. Now, what are the anions which are present in its vicinity to get stabilized? Chloride ions, right? Chloride ions. So, chloride ions, what is the source of the chloride ions? Saturated potassium chloride, which is being considered as an electrolyte in this particular electrode. So that is the source of the anions for getting stabilization of this Hg2 plus 2 ions, which are mercurous ions. Alright. Now, the question is, so since there are two cations, Hg2 plus 2 means, so what you will write? Cl minus 2. So Cl minus 2 will exist in the nature. Cl minus 2 will not exist in the nature. Because Cl minus is the monovalent anion. So since it is the monovalent anion, it will not be in the Cl minus 2 form. It will be in the Cl minus form. It will be in the Cl minus form. But here, there is a need to stabilize 2 plus ions. But we have only Cl minus 1, right? Now, what we need to do? What it will do? It will react with the 2 Cl minus 1, because it won't be in the minus 2 form. Since it won't be in the minus 2 form, each one of the chloride ions neutralizes each one of Hg2 plus 2. Now, so this is the next step. Next step is the stabilization of the ionic species which is formed in the first step at the anode, results in the formation of Hg2 Cl2 solid. Now these are the two reactions which are part of the anode. Now, in order to get the overall oxidation reaction, we have to combine these two reactions which are a part of the anodic reaction, and after combining, we have to cancel the equivalent ions or the equivalent ions if present on the opposite side of the arrow mark. If the equivalent ions or equivalent electrons are present on the same side of the arrow mark, we have to add them. So accordingly, what happens? So try to focus on the species which are there on the right side of the arrow mark and left side of the arrow mark. Don't be confused. Now Hg2 plus 2 Hg2 plus 2 has been formed in the first step of this particular oxidation reaction, which is there on the right side of the arrow mark. In the second step, it is there on the left side of the arrow mark. According to the statement what I have made, it is clear that it can be cancelled. Now, any other species can be cancelled. Electrons are not there, same ions are not there, only Hg2 plus 2 ions were similar, and both are, as they are on the opposite side of the arrow mark, they are being cancelled first. Now, what are left on the left side of the arrow mark, write those species, don't be confused. Whatever the content which is left on the left side of the arrow mark, write that content on the left side. So what is left? 2 moles of mercury plus 2 Cl minus results in the formation of. So now whatever the content which is left on right side of the arrow mark, write it only on the right side of the arrow mark. What is the content which is left on the right side of the arrow mark? Hg2 Cl2 solid plus 2 electrons. So these are the reactions which occurs at anode during the functioning of saturated calomel electrode. Now we have to discuss what are the reactions which occurs during the functioning of saturated calomel electrode whenever it acts as cathode. And what is that chemical which acts as a cathode, which I have discussed in the beginning, right? That is mercurous chloride. Now, it is very easy to remember the reduction reaction occurring at the cathode. The reduction reaction is exactly reverse that of the oxidation reduction. That is, Hg2Cl2 initially undergoes dissociation, resulting in the formation of Hg2 plus 2 ions and 2 Cl minus ions. Next step is Hg2 plus 2 ions gains 2 electrons which have been lost by the other electrode to which it is connected and gets reduced to mercury. Exactly reverse of this oxidation reaction is reduction reaction. Exactly reverse. What is that? Hg2Cl2. Hg2Cl2 solid undergoes exactly reverse. Don't be confused. Exactly reverse to that of the oxidation reaction. Hg2Cl2 initially undergoes dissociation, results in the formation of Hg2 plus 2 Cl minus. Now what happens? Next step is, don't be confused, next step is this one, right? Next step is this one. Hg2 plus 2 electrons giving rise to mercury. Hg2 plus 2 electrons gives rise to mercury. Right. So this is the reaction occurs at cathode whenever the saturated calomel electrode acts as cathode and undergo reaction. So in order to write the overall redox reaction, that is reduction reaction occurring in this particular saturated calomel electrode, we have to combine the two individual reactions which are occurring at the cathode, and after combining we have to cancel the equivalent ions and equivalent electrons if present on the opposite side, or on the other hand, if equivalent ions and equivalent electrons are present on the same side, we have to combine them, right? So accordingly, Hg2 plus 2 ions are there on the right side of the first reaction occurring at the cathode, and in the second reaction of occurring at the cathode, it is there on the left side, so both can be cancelled. The resulting is Hg2Cl2 solid gains 2 electrons, giving rise to, what is the content which is left on the right side? You are supposed to write 2 moles of mercury plus 2 Cl minus. Now, dear students, is there any need to memorize or mug up these reactions? No. There is a concept behind it. That concept is, just remember this concept. If you remember this concept, then it's very easy to write any of the chemical reactions, either it is organic, physical, or inorganic reaction, whatever it is. That is, nature hates to be in the ionic form. Nature hates to be in the ionic form. Once the ionic form of any of the substance is formed, the second step immediately will be the stabilization of either the cation or the anion which is formed in the previous step. Accordingly, you have to frame the reactions, but need not to memorize or mug up the. So now, students, we are going to discuss about the Nernst equation associated with this particular reduction reaction of the saturated calomel electrode. Now, what is the overall reduction reaction? Overall reduction reaction of this particular saturated calomel electrode is mercurous chloride solid gains the 2 electrons and converts to 2 moles of mercury liquid plus 2 moles of chloride aqueous. Now let us apply the Nernst equation for this particular reduction reaction of saturated calomel electrode. Now what is Nernst equation? A equals to E naught minus 0.059 by N log C. And what is the C? C is the concentration of the products to the concentration of the reactants. And what is the N? N is the number of electrons involved in redox system, because number of electrons involved in either the oxidation or reduction is one and same. They follow the first law of thermodynamics, that is energy neither be created nor be destroyed. In the similar fashion, electrons neither be created nor be destroyed. So that is the reason number of electrons lost during the oxidation is equals to number of electrons gained during the reduction reaction. So as there are 2 electrons involved in the reduction, that means that 2 electrons were a part of the oxidation reaction as well. So accordingly, N is the number of electrons involved in the redox reaction and the products by concentration of reactants. Now E equals to E naught minus 0.059 by number of electrons involved in the redox systems, or 2, right? So 2. So by 2 log concentration of the products. So what is the product here? Mercury liquid power 2. Next Cl minus aqueous power 2. And what is the reactant here? Reactant is mercurous chloride alone, right? Mercurous chloride alone. So Hg2Cl2 solid. Hg2Cl2 solid. Right. Now, do remember, students, that during the functioning of any of the electrochemical cell, neither the liquid moves nor the solid moves, only the ions will move. So as the ionic movement will be there during the functioning of any of the electrochemical cell, we have to consider only the ionic movement, and we have to consider the movement of other solids. That is, we have to consider the activity of the solids and the liquids as unity, right? So to remember that during the functioning of electrochemical cell, neither the solid moves nor the liquid moves, only the ions will move. That is, only the ionic movement will be there. So we have to consider only the movement of the ions, leaving behind the solids and the liquids as unity. So in this context, what we need to do is we have to consider the activity of either the solids and the liquids as unity, and we have to consider only the value of the ions. So accordingly, so this is the liquid, mercury is the liquid. So since it is the liquid, its value is unity, it is considered as unity. And Cl minus, it is the ion. So since it is the ion, based upon the stuff what I have explained to you, it is very clear that its value should be considered. Its value should be considered. It should not be considered as the unity. So Cl minus power 2. And mercurous chloride is a solid.
So since it is a solid, its activity should be considered as unity. Now, whenever the activity of the mercury, which is one of the product, and mercurous chloride, which is the reactant, is considered as unity, now this particular equation will becomes E equals to E naught minus 0.059 by 2 log. So this is 1, this is 1. What is the leftover part? Cl minus 1 to the power of 2. So now bring this 2 inside the equation. Now let us bring the 2 inside the equation. So let us bring the 2 inside the equation. So if we bring the 2 inside the equation, what happens? This 2 which is there in the denominator, and this 2 which is going to come to the numerator will gets cancelled. And when 2 gets cancelled, what is the leftover portion? So leftover portion will be, so whenever the 2 gets cancelled, so it will be log Cl minus, log Cl minus. So what we are going to get, the final Nernst equation for this particular saturated calomel electrode is E equals to E naught minus 0.059, because 2 are cancelled, log Cl minus aqueous. So now based upon this particular Nernst equation, it is very clear that this saturated calomel electrode functioning totally depends upon the concentration of the chloride ions. So since the saturated calomel electrode functioning totally depends upon the concentration of the Cl minus ions, chloride ions. So we have 3 types of calomel electrodes based upon the concentration of the chloride ions. So based upon this particular Nernst equation associated with the saturated calomel electrode, it is very clear that this particular saturated calomel electrode depends upon the concentration of the chloride ions. Now, since it depends upon the concentration of the chloride ions, so based upon the concentration of the chloride ions, we have 3 types of calomel electrodes. Now we are going to discuss those 3 types of calomel electrodes. So if the concentration of chloride ions is 0.1 normal KCl, so Cl minus ions are a part of potassium, so that is the reason KCl. So then the calomel electrode is called as a decinormal calomel electrode, and it is how it is represented. This is how it is represented, and standard reduction potential value of this decinormal calomel electrode is 0.338. This is very important. This is very important from examination point of view. This is very important from examination point of view. Just give me a moment. Right now, so this is how it can be represented, and the value of this particular decinormal calomel electrode is 0.338 volt. And we have another type of calomel electrode in which the concentration of chloride ion is 0.1 normal. So if the concentration of chloride ion is 0.1 normal, or concentration of potassium chloride is 0.1 normal, because 0.1 normal, actually it is 1 normal, sorry, this is 1 normal. So 1 normal, then the calomel electrode is called as a normal calomel electrode, and this is how it is represented. And the standard reduction potential value of this particular normal calomel electrode is 0.2800 volt. And coming to the last one, so if the concentration of the KCl is concentration of KCl means concentration of the chloride ions is saturated. If it is saturated, then calomel electrode is called as saturated calomel electrode, about which we have discussed now in this class. This is how it is being represented, and the standard reduction potential value of saturated calomel electrode is 0.2415 volt. And this particular values, these particular electron potential values, that is standard reduction potential values, are very important from the examination point of view. These questions will be asked in the bits. What is the standard reduction potential value of decinormal calomel electrode, right? So the standard reduction potential of decinormal calomel electrode is 0.338 volt, whereas the standard reduction potential of normal calomel electrode is 0.2800 volt, whereas the standard reduction potential value of saturated KCl is 0.2415 volt. So with this, we have done with this saturated calomel electrode, and in the saturated calomel electrode, I have demonstrated the construction of saturated calomel electrode, and I have clearly explained the reactions involved in the saturated calomel electrode, that is whenever it acts as anode, what are the reaction occurs in the saturated calomel electrode, and whenever it acts as cathode, what are the reaction occurs at saturated at cathode, right? And what after that, I have explained the Nernst equation associated with the saturated calomel electrode based upon by considering the overall reduction reaction, and with the help of the Nernst equation, it is very clear that this particular calomel electrode absolutely depends upon the concentration of the chloride ions, and based upon the concentration of the chloride ions, these calomel electrodes are classified into three types: decinormal calomel electrode, normal calomel electrode, and saturated calomel electrode. And the standard electrode potential of decinormal calomel electrode is 0.338 volt, whereas the standard reduction potential of a normal calomel electrode is 0.2800 volt, whereas standard reduction potential value of saturated calomel electrode is 0.2415 volt. I hope you understood this particular saturated calomel electrode. So thanks for watching.